A very good morning to each one of you. On behalf of Bangalore Chamber of Industry and Commerce, we welcome you all for this sixth in the webinar series on intelligence in manufacturing for artificial intelligence in manufacturing for enhanced efficiency and productivity. This is the joint initiative along with Maxbyte Technologies. And thanks to the team from Maxbyte for supporting the chamber in structuring and organizing this session. I'm Roopa, Assistant Secretary General at BCIC, and I am accompanied by our Secretary General, Colonel Harish. And the chamber acknowledges the support of Dr. Bibeye, who is the AI technologist at Maxbyte Technologies for addressing the members at this very important and critical session, sir. Thank you, sir, for your support.
This session is organized under the aegis of Industry 4.0 Expert Committee of the Chamber, chaired by Mr. N. Chandramouli, past President of the Chamber, and co-chaired by Mr. Jagannath, COO at M2 Next, a BFW subsidiary.
We are pleased to introduce Dr. Bibeye Jahaziel, who is the AI technologist, and he comes over 5 years of experience and has a strong foundation in developing solid lubricant nano composites for cutting tools and tribological applications. His research expertise includes working with techniques such as reactive sputtering to develop solid lubricant coatings, assessing machining performance, and utilized advanced characterization methods. He has a proven track record of assessing tool wear, tool life, and machining forces, and he has completed his doctoral thesis on performance investigation of surface modified cutting tools in dry machining of titanium alloys. And the chamber also acknowledges the support of all our annual sponsors for their immense support in all the activities of the chamber. I now request Dr. Jahaziel to take over from here. Over to you, sir.
So thank you, ma'am, for that wonderful introduction that you've given about me, and thank you, Chandramouli sir, for your wishes as well. Wish you a happy and safe flight. So just a minute, I'll just pull my screen out. So I hope now my screen is visible.
Yes, sir.
Okay, thank you, ma'am. So once again, a very warm welcome for this talk on artificial intelligence and manufacturing. And I thank BCIC for having me with you for this session as well. So there was a brief introduction about my career, and I think this talk, many of you might have a small doubt in your minds that talk that was completely about machining, manufacturing, and this is something which is totally in the other pole, maybe both the north and south. But still, my research was also based out of machine learning and artificial intelligence, and that is how my interests moved towards this side. And yes, since then I've been working with Maxbyte as an AI technologist, where we lead AI project. I personally lead AI projects and we have carried out many successful implementations and helped customers realize business value with the tasks that they are destined to. So AI everywhere. AI is the buzzword that we've been hearing, and every video that we see, every article that we read, everywhere artificial intelligence is something which has now become inevitable. And even in our day-to-day lives, we are not able to eradicate the word artificial intelligence. And now artificial intelligence has started taking over in every domain. Especially in the industrial domain, let it be to the software domain, software development part of it, or in the marketing aspect, or in the travel aspect of it. Each and every domain that we take for that instance, there is an artificial intelligence role that is being played. And even we, in our day-to-day lives, we make use of artificial intelligence, as a few examples that I put up on the slide, and the images that you can see also. When we have something that we need to, we have minimal amount of time. We want to summarize a document, or we want to just understand the glimpses of it. We go to the ChatGPT, put it inside, and ask them what it is all about. Or our personalized OTT platforms, for that instance, whatever recommendations that we receive is totally based on our own interests. And as we all know, Tesla, as you see here in the logo in this image, it is about Tesla that makes mankind's job even more easier in terms of automotives. And that is everywhere we see AI being used now. And now we move on to where we are focusing on, or which is our interest, that is AI in terms of manufacturing. In terms of manufacturing AI. So a few years back, it was like AI is developing, AI is coming up, AI is going to take away everyone's job, and every AI. That was the myth that was being very popularly spoken about. And now it isn't that AI is coming, AI is coming. AI has come, and AI has started to take over operations. It is like, I would like to say that AI is no longer a futuristic part that probably in another 10 years AI will be taking over. No, AI has already taken over. And our ultimate goal is to reap out the maximum benefit out of AI. That is how we harvest the full potential of artificial intelligence in our daily life operations. And as you can see here, there are numerous challenges that industries face, and how we overcome all that. Probably the improvements in efficiencies, the savings that companies realize, the reduction in the time consumption that occurs in carrying out conventional activities, and like all that. So if we have a talk with any industrialist around 10 to 20 years back, the situations then would have been totally different to what it is being now. From when I was personally into my research activities, when we started the research articles that I used to read, where they're all in terms of, it is like the precision, the accuracy, we talk in terms of micrometers and all that. And as gradually now, if we move on to all these activities, the precision would have not been no more in terms of micrometers. It would all come down to the range of nanometers and all that. So that is how improvisations are happening. This is one example that I could correlate in my domain or my expertise. And yes, as industrialists, people can also correlate in every aspect of them. So things were not as easy as how it used to be, or things are not the same as how it used to be. With every new advancement in tech that is being coming up, there is a demand that puts the bar is being set up even higher and higher. The bars are not still remaining the same. Earlier, if it was, for example, push your limit to 60%, now it is going to be push your limit to 90%. That is how the demand from our customers, or demand from the end users, is putting up a situation. And that is where the need for artificial intelligence comes into picture, where we try to reduce the human intervention, or the human efforts that are being invested are all trying to be reduced, and the inefficiencies that might arise out of continuous, repeated, tedious activities are all being tried to made much simpler. So in manufacturing operations, in a high level, and probably we will be moving on to each and every use case in specific. So on a higher level, how can I use AI? For example, take in terms of production. Demand forecasting and process optimization is one vital use case that most of our customers are very much interested in. And what is the reason being that they might be a production company that produces a particular, maybe you take it, for instance, a home appliance, or maybe industrial machineries. For example, take it for a home appliance. Then the demand seen for a particular home appliance will be high at a particular point of the time of the year. For example, now everybody is more interested in purchasing air conditioners at this point of the year. That is, we are in the mid of peak summer, and so everybody is more interested in having an air conditioner. So if an air conditioner company wants to plan for that, they must be in a situation that they should be able to meet the demands. They should not be able to say that they have stocked out. They would not be able to satisfy the customer demands. So that is where artificial intelligence comes into picture. How it comes into picture, how it helps customers realize their business value, probably when we go into depth, we'll be able to understand. And in terms of maintenance, maintenance is something which is, if we take for that instance, any production environment, the maintenance industry is something which is very busy. As when we interact with customers, we find very tough, challenging times bringing in the maintenance engineers for a discussion with us, either virtually or when we go and meet them. Finding their time is very difficult because they are highly occupied with the maintenance activities, and that is something which is not under anybody's control. So these are all there we can have the predictive maintenance, the anomaly detection parts of it, so that maintenance activities are planned, the machine is best utilized. And quality, in terms of quality, there is no compromise on with the customers. They are on setting up the higher standards. So there we have, for example, artificial intelligence, how artificial intelligence will help you. For example, a vision-based inspection system can come, a defect prediction system can come into place. It can help you identify that this is the defect that is coming up in this machine, or the part that is being produced out of this machine, and all that. Like, that is how artificial intelligence comes into picture here. And also for in terms of inventory, so our supply chain, the inventory prediction and the automated restocking comes into picture, where it has an impact on the just-in-time delivery, and also we do not overstock or we do not understock, and our demands are all met in time. So now we move on to the first segment of it, that is artificial intelligence in production planning. Just a minute. So artificial intelligence and production planning. So what is the challenge that many companies face now, or what is the need that artificial intelligence comes into picture? So conventionally, it was like this year we had been producing so much and so much of articles, X number of articles in product A, Y number of articles in product B. So now this year, the last year, we were able to meet the production demands, the demands, or the supplier demands were met. And so now this year we will be producing X plus Y or number of articles. So that was conventionally being done, and yes, the expertise or the knowledge that even experienced professionals bring, that is always inevitable, or that is always a highly valued one. In addition to that, there are other factors as well that are very much significant in having a production plan that is being made. So many factors, like for example, one factor that we could say is the seasonal factor, or one factor that we could say is advancements in technology that are coming up, or the customer demands that are coming up. All these need to be incorporated in terms of planning for a production. So that is where the artificial intelligence can help more with the customers, or help more with industrialists plan for the production that they are able to meet the customer demands. For example, in case of AI-based demand forecasting that is needed, as I said earlier, conventionally it was in one particular approach, and now what we do is we make use of the algorithms that are available, which can help you analyze the historical data, the sales data, the production data, the market trends, the current market trends, and also other associated factors I was talking about. New features might come up with a product, and all those associated factors are being associated or incorporated into these algorithms, where it will help you have a better accuracy of the prediction. The accuracy of the prediction will help the customers understand what they need to produce and how much they need to produce, and also the costs. At what point of time is this demand is peak, or at what point of time the demand is very minimal, the cost associated with the production of it, and also the inventory cost of it. So these are attributes that will be very much helpful, where customers are able to, the industries are able to plan for the activities, or plan for the upcoming time period. And also this will help us in an this decision-making part of it is very vital when it comes to artificial intelligence. And in every domain or in every aspect of it, this will help us to foresee to a greater extent. I don't see it as to a larger extent, but to a greater extent. Like for example, we will be able to know what we can expect, and that is not going to be any variation by a larger margin when compared to what has happened and what was forecasted. For example, another system that I use case that we commonly come across with customers is the MRP system, where traditionally they struggle with handling the dynamic changes in production schedules, and as we said, as we have been talking about the suboptimal planning levels and all that. So here also we bring into an AI-based MRP solution where we use the machine learning algorithms to enhance the MRP operations. That is the real-time data, the predictive analytics part of it, and also the material planning, the inventory management, and the production scheduling are all made more easier with the help of artificial intelligence. So it understands what is required and how it is required. Yes.
Bye. See you all. Bye-bye.
Yes, sir.
Thank you,
Yes,
Dr.
sir.
Bibeye.
Thank you. Thank you.
Thank you, Dr. Bibeye. Bye.
Bye, sir. Bye. So when it comes to the benefits that we customers generally reap out of it, the efficiency gains are higher. The cost savings that customers tend to realize through the implementation of these production planning systems is even better, and also the accuracy. Accuracy is greatly improved. So this was one customer that we came across with. They are a global agribusiness and a food manufacturing. They are in a food manufacturing company, and they were not able to. The problem that they were facing was they were not able to meet the customer demands. There was since as we all are witnessing these the food manufacturing or the this industry is highly dynamic. There is a different trend that is being followed every time. So that was one thing that they were not able to forecast, or the lead times were not within the expectations. So that was one problem that was put up, and we were able to pitch in the demand forecasting and the production schedule optimization, and we made a use of different data sources that they had, and all the entire data that they had, the historical data that they have been preparing or they have been storing for a long period of time. We made use of all those historic data, and we were able to bring down the challenges that we were able to address these challenges that they were facing. We were able to forecast with a better accuracy. We were able to have an efficient production environment. The decision making was even better. Our customers were able to understand what was happening, and yes, they were also able to make a considerate revenue out of that, out of the artificial implementing this artificial intelligence system. So this is a production environment. This is how a production environment works. And now we move on to the next key domain that we generally when we face generally when we interact with customers: artificial intelligence in terms of maintenance. So maintenance is a very vast domain that we are closely working on with customers. So this is also talking about this slide also talks more about the evolution of maintenance, how it has evolved since the initial days, and now how it has turned out. Initially, it was all people talking about the reactive maintenance activities. That is, equipment fails, and then we take out the essential maintenance action. And then people start to move on towards the preventive maintenance activities. So preventive maintenance activities, we have a fixed timeline. So that maintenance activity is being carried out at that particular point of time. So what happens here is, in terms of the reactive maintenance, there are certain limitations. That is, we do not know when that is going to fail. So we might be facing some production losses as well. And such instances were countered here, and they were all rectified in terms of preventive preventive maintenance. But what happens here in preventive maintenance is at times we tend to overdo the maintenance activities. That is, there would have not been any maintenance need for the machine, but there is a maintenance activity that is being done. Yes, the machine is good. The machine is put to full use, full utilization. It is operating efficiently. But yes, the cost associated with these maintenance activities is all incurred. And how now industries are gradually moving on to predictive maintenance activities. So what predictive maintenance is, we have large volumes of data from these machines. We know how these machines are operating, what condition these machines are operating, what is the health that these machines are now. And with that, we will be able to know that when there is a failure that is going to come up, we would be able to forecast, or we would be able to understand or visualize that this is a deterioration trend. So we need to have some maintenance activity, and that can be planned. It is not like the machine is going to fail today and you understand. It is not the case every time. Most of the time it would be, well in advance. It will be a smaller, it will start initially and to a smaller extent, and then it increases. So reactive maintenance, the benefits that we were able to associate were, there is the low cost associated with the maintenance activity is lesser. No complex infrastructure is needed, but the loss that we have incurred is the downtime is higher, because when I say high downtime, if there is a critical component that is being failed, the lead time associated with that is also accounting to the production. So there is a production that is being lost, and yes, the safety of these employers is also put to risk. And when it comes to preventive maintenance, the cost associated with the maintenance activities is higher, and the manpower utilization, thereby the manpower utilization is also high. And when in terms of predictive maintenance, it will be like the benefit that customers realize is the unplanned downtime is being reduced, the lifespan of the assets also gets improved, and the maintenance activities are targeted. But one certain limitation is we require considerable volume of data for building up all these activities. So how these predictive maintenance is best utilized, how we can visualize it. So for example, when we say there is some failure that is going to come up, when we have a vibration analysis, for example, there is a compressor running inside in a machine, and that compressor has got some failure that is coming up. Let's say a bearing is undergoing severe wear and tear, and yes, there is a need for the bearing to be replaced. The vibration levels in the bearing will be very higher, and that generally bearing vibrations don't reach the peak within a very short span of time. They gradually the wear gradually deteriorates, and when there is a vibration analysis that is in picture, we will be able to know that this is going to fail in so much amount of time based on the data that we have, or based on the bearing databases. We would be able to understand, or we will be able to know that this is something which is upcoming. So what customers or what users will be able to do is, they would be able to plan for the production activity. As industrialists, when we go to customers, what they have got, what feedback that they give is, this is an observation that we got from the dashboard, and we have planned for the maintenance activity this week off day. And probably they can complete the critical productions, all that is needed to be completed. And yes, it is within the safer limits. Maybe it is not operating at 100%, but yes, there is a change that is going to be made. So let it operate at 80%, and we complete the production activities. Yes, ultimately, it is a win-win situation for the customer. So that is how predictive maintenance generally works. And in general, what customers are challenges our customers are facing is because of in terms of maintenance, there is the unplanned downtime is very higher. The cost associated with maintenance is higher. The performance deteriorates as these machines or as different components are failing, and thereby it leads to quality control issues. And so when the technology solution that we come up with our customers, or are generally in the industrial environment, is we go for the installation of sensors, or in the modern day machines, it is all data retrieval from the PLC system, and we put a condition monitoring system in place. And with the help of a condition monitoring system in place, customers are able to know what has gone wrong and which part of the machine is not operating in the as expected condition. So through that, they will be able to know there is an anomaly that has happened. This anomaly has to be identified. This anomaly has been identified by the system and it is shown to the user, and the user takes a corrective action to bring that in picture. For example, as in terms of a machine, any for a dryer machine, we say that the suction pressure or a discharge pressure needs to be within a particular limit, and the discharge pressure is going beyond the set limit. So what our customers will be able to do is they'll plan for the maintenance activity. They will be able to know that this has gone wrong. So and eventually, if a machine fails also, they know when they go for the past historic data, they will be able to know that this has been not functioning as expected. So we are to look at this part, this particular part of the component, rather than the maintenance technician coming and spending hours of time on identifying what has happened. So this will help the customers, help our customers, or help the users realize a targeted maintenance activity. And because of this, we customers are able to have the reduction in the unplanned downtime, improved asset life, and also the maintenance costs associated with it is getting reduced. And this is how a general schematic is working. We have the installation of sensors, suitable connectivity is done, and the operational technology and IT technology integration is done. And yes, different aspects of it, and it can be a time series data, it can be a non-time series data as well. All these parameters are taken into consideration. A condition monitoring is initially enabled, and followed by that, the performance characteristics is also understood. The data and a few analytics comes into picture here, the data pattern, the anomalies, the trends, and we build the machine learning models for the failure prediction based on the historic data that certain customers will be having, or on the database. We make use of the database. For example, in terms of bearings and all that, we will have that there is a large volume of database that is being provided by the bearing manufacturer. So all these will help the customers realize this predictive maintenance to its full potential. And based on this, our customers will be able to have some actionable insights, and there would also be a maintenance proactive action. And in case of certain advancements, we would also be able to have the scheduler and the workflow, the mobile work instructions, and AR-based know-how are also being given to certain customers who want an advanced level of integration. So in general, an implementation roadmap, it is like initially we start with the business case development. We pitch in with customers, or for any activity to be taken up. The business case, the real need has to be identified, and then we initially go for the feasibility assessment, the objectives, the machine that requires the system, the predictive maintenance system, and all that is done. And we have the data phase. The data phase is very critical in terms of predictive maintenance, because these models are all data thirsty. So they would require large volume of data. So we collect in around 6 months or 9 months of data. We build these models. The data engineering aspect occurs there, and also we build the models, and the model performance is being timely monitored. And as time progresses, these accuracies are highly improved, and they help customers realize a business value to a larger extent. At a higher level, the architecture would be like the machine, the sensors installed, or in certain systems, it will be like the system sensors are already connected to the PLC system, and the data is being flowing inside. Initially, it is to the IoT platform, and from there, it moves on to the analytics platform. And yes, in the end user receives it in terms of the dashboard or in terms of a mobile application. And another interesting part of it that we have also provided to our customers in the past is the automated RCA kappa, the root cause analysis and the corrective and preventive action. And here what we do is we bring the generative AI part into picture. Probably I will talk even more about that in the generative AI topic. So we would be able to help customers have the automated root cause analysis and the corrective and preventive action. So what happens happens here is there is the dependency on a particular personnel is being reduced. For example, a maintenance engineer, he might be very well versed with the machines. He knows what is going wrong, or what if there is something which has gone wrong, what has to be corrected. And that person is unavailable for a particular period of time, or he takes up some other assignment in the meanwhile. And it is not that every time the KT can be done very clearly, or every time the knowledge is the other employees are also well versed with that. So this automated RCA Kappa systems comes into picture, where it will either fetch data from the past and give us the corrective action that has to be taken if data are available, or from the user manuals the system can fetch the data and give us what is the corrective action that has to be taken. So along with the predictive maintenance, this is essentially a game changer that what we face when we meet with customers. A couple of case studies that we have come across. Initially, this is a dryer machine, and the ultimate objective of this dryer machine, it has to have the output of the dryer machine has to have a lower dew point, and the moisture has to be very minimal, because this is given as the input to the paint shop of that particular manufacturing company that we were implementing the solution. So if there is any amount of moisture beyond the threshold limits, what happens is the quality of paint is deteriorating. When it goes to the QC, it gets rejected, and then it has to be either scrapped or it has to be reworked. So that was one challenge that our customers were facing, and also this dryer had a compressor, which was very crucial in terms of the production, because this is the input to another. This output of this machine is the input to another department. So this dryer was very crucial. So the solution that we implemented was, we initially started with the condition monitoring. We started monitoring, and we identified that there was something abnormal. The discharge pressures were varying from the exact limits that they need to operate. The anomalies were detected. The customers were also alerted on this through the dashboards that we provided, or also through the mobile applications that they have. And the vibration analysis were also implemented, because compressor was very critical for them. And with the help of that vibration analysis, we were able to have the time to failure prediction. And one thing was, they were able to have the abnormal discharge pressure. Another problem that customers faced was there was an abnormal vibration signal. And when these vibration signals were analyzed, it was identified that there was a potential compressor imbalance identified. And the maintenance team had discussions with the production, and they had planned for the maintenance activity. The interim activities were all planned, and they were able to have the machine up and running without any unplanned delays. So through this, they were able to realize a 5% improvement in the operational efficiency, and a 22% reduction in the anomalies. When anomalies I refer to, it has ensured that these machines are all operating as in the expected conditions. And another machine that another customer we interacted with was in this machine. It was a hairpin bender machine, where it will produce bends of copper tubes. And there it was one thing which was very critical was pressure. Pressure was very critical in that machine, because for the quality of bend that it requires, the ideal pressure conditions had to be maintained. And that was initially the pressure was all developed through the hydraulic system was powering the entire system. And when we implemented condition monitoring, we were able to identify that there was this oil temperature component was very higher at a particular point of time. And it was identified that this temperature rise was not normal. And when examined, the viscosity of the oil was not within the expected limits. And yes, and immediately they were able to have this maintenance activity planned and executed. So through this implementation of predictive maintenance, anomaly detection part of it, we were able to have an improved operational efficiency for our customers. We were able to tell them that this is going to fail, or this is going wrong continuously. So this needs to be taken, the corrective action needs to be taken for this. And customers were able to realize unplanned downtimes. So this is with respect respect to maintenance, the role of artificial intelligence in maintenance, here to summarize with the maintenance part of it, customers were ultimately able, in general, the business user is ultimately able to have a reduction in the unplanned maintenance downtime. So through the implementation of condition monitoring, anomaly detection, and the time to failure prediction part of it, customers will be able to realize the business value. And another critical department that we come across very or quite often, or in most of the industrial environment, is in terms of quality control. Quality is the quality standards that are being set up by customers, or are the company themselves, the production companies themselves. The standards that they set are really higher nowadays, and there certain challenges are being put forward. So most of the time, challenges that are being faced in the quality department or quality control is the manual inspection errors. It is like repeatedly looking at a particular component or looking for issues or any different types of failures or any signs of fracture or crack or anything. There is a tendency for the human mind, or if there is a chance of an error that is being coming up. So that is one challenge that customers are facing, or it is like delayed defect detection. The parts are produced, packed, sent to customers. There they find out that this lot is completely faulty, and then maybe or in the even at the department where it is being checked before dispatch, at that times it is like it is a delayed process. So there also the cost associated with the process that happens post production is also, there is something which is a matter of concern for customers. The in terms of rejection, the scrap and the rework rates are also a concern. And yes, there is data coming up from different ends. That is that there will be a customer who's supplying the raw material to this manufacturing unit. They will be having a particular supplier might have records of producing defective products, maybe at a higher rate when compared to another supplier. And all these data will interaction of all these data or integration of all these data is a quite challenging task in terms of the conventional approaches. So how AI comes into quality control, or how AI can enhance operation in terms of quality control, is we suggest computer vision for real-time inspection. So this will be this is one game-changing system that is being widely adopted by industries nowadays, because it is like online. You produce it, the parts are being produced, it comes out in the conveyor, the defects are identified, yes, and it is done. You take this part out, or these are the parts that need some particular specific attention and all that. So that is something which is very vital to the industry. And the quality analytics part of it, the machine learning models predict the defect patterns based on the process data that we are receiving, or the anomaly detection part of it, as we saw in the predictive maintenance session, and the automated reporting and traceability. In automated reporting and traceability, that is, we implement Gen AI, and that this part of it, the automated reporting part of it, will be elaborated in the next session. That is where generative AI comes into picture, and the continuous learning models, that where it is like each and every time the models are getting updated. It is like a continuous self-learning process where the accuracy is getting improved more as we have more and more images that are being inspected. For example, the accuracy when the vision system was implemented, maybe around 75 to 80%, and as and when these models are learning more and more data from more and more data, the accuracy generally improves. And yes, through this, customers have been able to realize more amount of time reduction in the inspection, and the defect rates are also being brought down through the implementation of artificial intelligence systems, and also considerably a larger volume of cost that is being saved by the customers. So this was also with one bearing manufacturing customer. That this is business cases from one bearing manufacturing customer. So they had, as we've been talking again and again, these standards are being set up very high. The quality standards are not being able to be met at particular point at certain times, and the human errors, like when they are continuously with the help of a focus light, they're not able to continuously identify these defects, and that the certain defects to the human eye it might seem to be okay, it is a go product, but to the machine system or to the end user it might be a no-go product. So that certain instances are being bypassed, so that they wanted this error to be reduced, and also the cost associated with that, and certain complex defect diversities. Yes, as I said earlier, these complex defects such as oil film inconsistencies, when there is a heat treatment that is being done, the anomalies that arise out of certain process fluctuations are all not being easily tracked out. And so these challenges were put up by a customer, and we were able to give them an automated vision inspection system. And in this optical inspection system, they were able to address most of the challenges that they were facing through the high-end computing systems. They were able to the frames per second that was done 2 milliseconds per frame, and they were able to have a higher level of accuracy because of these systems. And with time, the model accuracies were even higher, so that most of the challenges, the main challenge that they were facing was it is a no-go product. The customer, we identify it as a go product, take it to the customer, they say it is a no-go product. So through this, they were able to identify to this system. They were able to realize that challenge that they were facing was sorted out, and through that, the cost associated with all these, the shipment or all the logistics part of it was all identified, and it was all reduced, and so better work outputs were extracted with the help of a system. So we improved the yield and stability of the production part, and this helped a reduction in the manpower, where it is like tediously a person sits or at a particular for different time frequencies, employees are made to sit and have the visual inspection part of it going. It is like it is not essentially that more number of employees are implemented in this part, where they can be effectively utilized for in case of other instances. And that is also, it is a closed loop production system. When I say a closed loop production system, we know that if there is a certain defect that is coming up repeatedly from the past data, we might be having also reasons for that, so that the system production team will also be able to understand that this has gone wrong, this needs to be corrected, and this needs to be looked after. So such is the a closed loop system that we would be able to produce, the build out of this automated optical inspection system. And now it is the most interesting part, I believe, because generative AI, generative AI, generative AI, it has been the buzzword. And in the recent times, generative AI is evolving to a larger extent. And everybody, for that instance, industrialists and people that we interact with, everybody for that instance is more interested in bringing out the generative AI potential to how they can best utilize in their operations. So in terms of generative AI, it is like it can help you do anything that we want to. For example, if you want to generate a new content, a marketing content, or a new production for any title, anything for that instance, whatever we think of we want to do, generative AI is able to do that. And yes, if we could all recollect a couple of weeks back, the Ghibli was very much into the trend, and everybody was very much looking forward to create their own pictures or things that they like or people that they like, their pets and everything. And that is how these are all evolutions in generative AI. And when we think of generative AI, the first thing that comes to our mind is OpenAI's ChatGPT or Copilot. And when it comes to people of different with different responsibilities, they might also have different tools that they are very much familiar with. For example, if it is a researcher or if they are teaching professionals, they might be interested in certain particular generative AI tools. And yes, it is all customized as per the role that they play. So fundamentally, generative AI is very good at generating new content. It is very good at summarizing the existing content, and and in such a manner that it summarizes the data or the content that we give it. It is in a way that it is easy to understand as how I require. For example, a CXO or a CIO of a particular company or a CEO of a particular company wants to know how the production is performing. They would not be able to look at the large volume of Excel sheets, or they cannot get into the database, query the database, fetch the data in a way that they like. It is not that it is like they don't have time for all that. So here, generative AI comes into picture. You put it in your own language, and receive it in a way that you need it. So and generative AI is very good at putting up conversations and yeah, performing chain of thought activities as well. So how is the evolution of generative AI now? And yes, as we can see in terms of supply chain, inventory management, the first half of 2024, the last year, this is a survey that was put forward by McKinsey. And in that survey, we would be able to understand, or we are able to see that even in the entire 2024 last year, the first half was not as fruitful or as effective as it was compared in the second half. The second half saw a drastic improvement. That is, most of the time it was greater than 10% in terms of each and every domain. And yes, in terms of industries where they make use of supply chain, inventory management, when it was initially it was 5, and when the second half it has gone to 19, and in every domain there is an increase and none of the departments or none of the domains have seen a downfall in this utilization. And in terms of manufacturing, also, these are the prime areas where Gartner has forecasted that most of the growth would be on impact of the generative AI, in terms of when it is an impact as a percentage of functional spend, and it is the impact in terms of $1 billion. And most of the time, it is like you can see here, customer operations. Here is it. This is the field where generative AI is more widely utilized, but still there are product R&Ds that are being utilized. Marketing it is being utilized. Manufacturing, it is an evolution, and so yes, it is gradually improvising. And generative AI, and now it is the generative AI talk has gradually evolved, or it has taken turn to generative AI agents. So what is the difference between a generative AI tool and a generative agentic AI tool? So what is agentic AI? Agentic AI is something, it is like a crew or a team that that will be able to do the repetitive activities that one particular person is needed. A person does. For example, this is an agent system. We have a manager agent here, and this manager agent has different tools inside him. There is an analyst agent running inside. The analyst agent is coordinating with the checker agent. The checker agent is coordinating with the planner agent, and these are outputs to the manager agent, and the manager agent coordinates with the external systems, that agents that interact with the database and systems, like it will be the organizational data or the external data. So how the flow of this entire system is, you provide the instruction in your own natural language. The agent system will, the manager agent will be able to plan, allocate, and execute the work. So that is how the agentic AI works. And this agentive system iteratively improves the output, and it ultimately executes the action that is being required. So for example, now we have an application. This is our own product. So this will help you summarize the condition. We have this was built for as a pilot for one of our customers, and that was where they wanted to have the summarization of a particular data and for a particular machine. And as in the determined period. It has given us, we just asked fetch condition monitoring data of Harish machine during the month of August for the first 15 days. And it has given the entire, all the parameters that are associated with the Harish machine is given here. And also the values that are associated, the minimum value, the maximum value, the average value, the number of alerts that were generated during this particular period, and also the duration of these alerts were also generated. And one highlighting feature with this is you can also be able to download this in as reports. For example, if it is as a CSV file or as PDFs, customers will be able to download it as reports. Where this comes into, this plays a major role, or this plays a business benefit to the customers, is this will help the customers in reducing large amount of time that is being spent in the data analysis part. You need not draw these data, download these Excel files. These Excel files can be or need to be plotted, or some operations need to be done, or a data scientist has to come and analyze all these data. These are all being reduced, and so that a fruitful work is being done, so that the time associated with that is being saved to a larger extent. And here it is visualization. If wanted, this agent will visualize the data as graph. As you can see here, different parameters associated with this machine will be generated as graphs, and these can be downloaded either as individual images or as in terms as a PDF file. And as I said earlier, in the predictive maintenance part, it is about the automated RCA kappa. Here it is not an automated RCA kappa, it is a manual RCA kappa, where you just give the problem that you're facing, the probable causes and the remedies will be fixed. This is initially done from the user manual that the vendor provides, or the customer provides to them. And in cases where customers have large volume of maintenance data in Excels or as PDFs, or even as papers, maintained at papers, these paper digitization is very easy now, and these can be digitized, fed into the system, and they can also, from there, data can be fetched, and customers would be given with the root cause analysis and the corrective and preventive action. So this is one interesting scenario where generative AI plays a major role in helping customers realize the business value. It makes tasks much easier. So, and this is a simple, just an illustration slide where different potential use cases have been identified in terms of the planning and the product development team department. You can create new product concepts, discover new materials, predict product market fit. And in terms of planning, production planning and procurement, it can be developing production plans, new supplier profile across sources, the screening of it, the summarization of it, as we saw now. These activities can also be incorporated. And in terms of performance maintenance, health and safety, it is like you create employee training videos on maintenance, troubleshooting, role plays, standard operating procedure documents. Your documents, large volume of documents can be analyzed, as I said, and automated suggestions can be given, identifying hazardous working conditions through video analytics. When it will also be this AI system will also help employees to a larger extent in terms of identifying hazardous work environment. Video analytics will come into picture. It will identify which employees wearing safety equipments, which employees are not wearing safety equipments, which employee is beyond his workstation, which employee is not available at his workstation, or at what point of time employees are not available at workstations. These are all systems that will help users make their task even more easier. Predict the machine failure modes, adjust the production orders in real time based on the data that is coming in, and also the performance updates, that is like as chatbots. So in general, the adoption approach for generative AI, because most of the time customers, when we face customers, like what is the plan that you have, or what is the approach that you take for this, is what generally asked by anybody who's interested to look at generative AI. And this is an approach that we generally put forward to them. We initially explore, or any company for that instance who would like to deploy generative AI, they can identify the potential use use cases where they think or they feel that generative AI will be vital. They can identify the pros and the cons with this, and probably based on that, we can go for the data that is available, the readiness of the data, how much amount of data, how much volume of data is available, the cost benefits of it is being analyzed, and yes, we select business values that are very significant or that are very vital and develop them as pilot projects. And for the pilot, it is like building up the solution, proposing the solution architecture for them. The implementation roadmap is put forward, and post that, it would be moving forward to the scaling up and the innovation part of it. In the scaling up part of it, it can be done for system integration, like integrating with third-party systems or third-party ERP or MRP applications, or third-party apps for task creation. Anything for that instance is made being possible now with the help of generative AI, and bringing forward new innovations in terms of making enhancing the customer experiences. So what generally customers are able to, the business benefits that they are able to realize is the time that is being spent on complex reports or data analysis is being drastically reduced. A faster root cause analysis, the downtime is being reduced to a certain extent. The product development life cycle is made even faster. Better demand forecasting is put forward. The personal dependency, employee dependency is being greatly reduced, and the data retrieval time by a larger extent, because you need not keep access the database, query the database, fetch the data, analyze the data, plot the data as graphs. It is all done with in a few seconds by just typing what we need in our own language. And so ultimately, we've come to the fag end of this talk now. And ultimately, to summarize AI in manufacturing, we have been focusing primarily on 4 different domains. One was with respect to the production planning. In terms of production planning, it would be helps the customers have a planned, enable them have a planned decision making, a better plan, though it is like they know what they are going to produce and how the market is being the market trends are now, and the decision making is even better, even fine tuned. And in terms of quality control, the inspection systems that are being put into place now, how it helps customers reduce the manpower that is being put inside, or the errors that arise due to repeated works, or fatigue that might cost as a result of the repeated works. These are all controlled to a greater extent. And in terms of maintenance, through predictive maintenance and automated RCA Kappa, how customers will be able to plan for the production activities or the maintenance activities. The lead times can be balanced, the cost associated with it can be balanced, and all that. And generative AI, the keyword, that the buzz that is going around us now. In generative AI, it can how generative AI is helping, and now we are moving towards an era where agentic AI has come into picture. How agentic AI is helping in documentation, the visualization, the retrieval of data from large volumes of databases, and everything is being has been thrown light to. So how AI is expected to evolve as in the upcoming trends or upcoming era, probably maybe in 6 months from now, these 4 points or 5 points that we tend to look forward now might have been realized, or maybe even now things have started to realize that even maybe in advanced industries, things have started to realize as well. Self-optimizing production based on the dynamic inputs, systems will be able to adjust accordingly. And generative design and production. And generative design and production is something even which we have also started to work closely with. The development of components or the product designs are made through natural language, and with the integration of design softwares that is coming up as a new product very soon, and AI agents as digital co-workers. As I said, reporting You need just to type, you just need to type what you want, and within a few seconds, the data is downloaded as reports, either as a CSV file if you would like to, or as a PDF file if you would like to. That is all easily available, and that is how evolution or AI will play a major role. And yes, the data from different sources like machine data, the employee data, the process data, these are all made as a closed loop system, and it will be helping industries perform even better. So ultimately, to close it before we finish, just put a word on AI, how AI has transformed manufacturing, or how AI is helping manufacturing. It is not only about the automation part of it, it is about the augmentation, the precision, and the agility unlocking at a larger scale, helping customers realize the business value. And that's it from this talk. Thank you for patiently putting up with I think maybe you would have loaded more and more of things in your head, but still, yes, I'm thankful to you for putting it up and being patient throughout.
Thank you, sir, for your exhaustive and wonderful presentation. It was very knowledgeable, and I also would like to thank all the participants. This session has witnessed more than 225 participants, sir. Thanks to the subject, thanks to you, and the audio and video we have enabled for the participants. I would request you to kindly share your questions, please. One question from Mr. Prem Shenoy. Any example of use of AI in root cause analysis?
Is it like put in the chat, madam? Any okay?
Yes.
Any
It's in the
example
chat
of
box, sir.
use of AI in root cause analysis? I think that was the presentation. I have it in the presentation slide. I'll just put it up once again. So Prem Shenoy, I think.
Mic accept first.
So
Please go ahead,
Prem
sir.
Shenoy, this is one scenario for where we would be able to have the root cause analysis. And in another use case where we are talking about automated RCA kappa is in terms of automated RCA kappa, we would be having a system that will identify what has gone wrong. For example, you have a digital dashboard. These data from a machine is flowing inside. Suddenly, this same problem rises up. Low suction pressure comes up there. The generative AI system will automatically be able to identify this has gone wrong. Will be able to create a query based on that. Will be able to fetch the data, the corrective causes, and the remedies. So you need not come here and look for the data. You need not go to an application and look for the data. It will all be made available as in a dashboard as well. So that is what we talk about automated RCA kappa. Now, I hope I answered.
Hello.
Yes, please.
Hello, Doctor. This is Ganapati Raman from Makino. Could you just brief about this generative AI?
Yes, Mr. Ganapati Raman. So, is it like you would like to know specifically about any particular application or any particular use case, or in general? Let it be in general.
Yeah, you can start with general. Maybe I can check with respect to my work, and maybe if anything is there, I can raise a query.
Okay. I think I can move to slides once again. Sorry for putting up slides once again. So now it is earlier it was like we started with generative AI. Generative AI for that instance, for in terms, I think you are as you said, you are from Makino, right?
Yeah.
Mr. Ganapati Raman. So primarily machine tool manufacturings.
Yes, right.
Okay, so in terms of machine tool manufacturing, machine tool manufacturing, I believe that the production data, I think the process data, all these can be integrated with the system, with the generative AI system, and that will help out. I think that will help out to a larger extent. For example, in this scenario, as you can see in my slides, we have summarized the condition monitoring data. I think condition monitoring is something which you must also be familiar,
That
sir.
will be the most appropriate one.
And yes, I think so. You can summarize this data, and it is not that for
I
this
think
is for
the slide is not presented, sir. You have to.
Okay, is my
Yes.
slide not visible?
Yeah.
Just a minute.
Is my slide visible now?
Yes.
Yes, Mr. Bibeye.
Yes, I think then. Thank you.
Visible.
So, Ganapati Raman sir, this is an application of agentic AI that we were talking about. In this data, it is like condition monitoring data of one particular machine, and we have asked for the summarization of this data, and it has given the minimum value that it was operating, the maximum value, the average value, the total number of anomaly alerts, and the duration of these alerts have also been generated. And this can also do with images as well. So in terms of if we want to have it as a visualization, we can also download the same as images as well, sir. So I think this is one vital application that we are putting forward to our customers now also.
Understood. So basically, it will be built in with the machine itself.
Yeah, it is like analyzing all the data that we have. It is not, this is just one example that we have showcased, and that can also be replicated for any other activity that requires complex analysis and repetitive tasks.
Understood, sir. Thank you.
Welcome, sir.
Mr. Ajit, you have raised your hand. Please go ahead with your question, sir.
Yeah, hi. Hi, this is Ajit. So in terms of predictive maintenance as such that you were experiencing, just wanted to understand like how are the requirements that you get? Is it like the data set that will be already trained? Like you'll get a data set which is new as of, or like you already have a system where you just go keep them so that you will get the trends out of it?
It is both the ways, Mr. Ajit, because in certain cases, for example, as I said, in case of bearing vibration and all that, the database is already available. So the system it is straightforward development. In certain cases, it is not going to be the same. And in that cases, we go with the customized model development aspect. So we go beyond limits at times to simulate certain scenarios, and that is all possible with the state-of-the-art AI and ML models.
Okay. And anything that this analysis that you have done is all on cloud-based or on the edge-based?
Certain customers require as on-prem solutions, and so it is either way. It can be done on cloud as well as on-prem as well.
Okay. Oh, okay. Cool.
So this the environment isn't constrained so far.
Yeah, so always like whenever you get the requirements is about the environment constrained only, right? Or they won't support for
because
cloud.
conventional organizations or conventional manufacturing companies, they don't prefer cloud solutions. They still they prefer to have as an on-prem solution, and they provide the on-prem infra as well. The on-prem server facilities are all being provided by them, and we pitch in and we do the necessary installations and all that. Or it is in cloud environment, we initiate the infra requirements, and yes, they provide it and we take it up.
Okay. Got it. Yes.
Thank you.
Ms. Deepika, please go ahead with your question. Mr. Mohammad Farooq.
Thank you. Thank you for the presentation given, sir. It was very informative. Basically, my question is like, we came to know how this means, what all the areas where this AI application has been done. Just wanted to understand, like, what were the tools used to do the analysis and all, like programming aspects, what all tools were used, whether it is like a normal programming method using some Python or some coding method, or whether like a general algorithm has been developed by your company, like that. That area just we wanted insights.
Okay, so in terms of the predictive maintenance activity that we were talking about, it is like every aspect. The backend is ultimately on Python, and the front end application it varies as per the customer requirement. Most of the time, we go on with React framework for the front end, and in terms of cloud implementations, we make use of AWS services. For example, in machine learning model building, we make use of SageMaker, and in terms of generative AI and all that, we make use of Bedrock. These are the services. And in terms of on-prem implementations or these generative AI applications, we've done it both with open source and closed source. In terms of open source, we make use of Facebook's Llama model, and it is powered by NVIDIA platform.
Thank you, sir. Thank you very much.
Welcome.
Sir, adding to this, I have one more question regarding the confidentiality. As you said, we can use the OpenAI source, everything. So how suppose if I'm using an organization data to generate the AI solutions, so how the data will be confidentially stored, or how to go about this?
I think at present we have all the guardrails being implemented, and we do not use the model. We do not use the organizational data to train these models. The models are already the pre-trained. We generally use pre-trained models, so data leakage is not the possibility of data leakage is very minimal.
Okay, sir. Thanks. Thank you, sir.
Welcome.
Mr. Sitaraman, please go ahead with your query, sir.
Yeah, good afternoon. I know this presentation was about AI in manufacturing, but I just thought I could raise this with you. Since you said, marketing and sales is one of the most popular use cases for generative AI. I'd just like to know as to how does one source data, especially suppose you are a startup and you've entered a market and you're looking to market your products or services. How do you use AI from the perspective of having enough data which you can feed and train a model to give you solutions to, say, for example, please generate the most ideal customer profile for me, for my products and services. If that is a problem I'm trying to solve, can you just throw some light as to how do we approach this kind of thing?
Okay, so you would like to take it up more in terms of marketing aspect, right?
Correct, yeah.
Okay, I think not much of familiar with this in terms of marketing aspect, because my primary role is all with this. But I think our agents can be customized to do the activity that, as I said, for example, I've been talking more about analyzing these large volumes of manufacturing data. So it is like you have the customer data, or you need to know more about the customer pattern, the customer trends needs to be identified. You want to know about the source also, right? Is it?
Correct, yeah.
Okay.
For example, in manufacturing, you have your own machine data is available to you because you've been manufacturing and you are tracking the data of your machine performance and stuff like that. So that data is readily available for you to draw some intelligence out of that. But from the marketing point, you have to know something from the external environment. So how do you access such data, and how do you kind of use it? So I just want to understand. I understand this.
Understood, sir.
Manufacturing.
Yes, understood. So like web scraping is not a huge task with now with the advanced LLMs coming into picture. So it can refer to different authentic sources that if you would predefine them, it can refer to, or if you would also ask for the any particular sources, the model to identify any particular sources, the applications are able to do that. I think ultimately web scraping will be a easy task for the applications, Gen AI applications to take up.
I see. Okay. Right. Thank you so much.
Yeah.
Mr. Mahesh Bhupati. So please go ahead.
Trial.
Or Mr. Girish, you have any questions, sir?
Yeah, yes, madam.
Please go ahead.
Yeah, I am Girish Kumaste and also a president of Kamagundan Small Industries Association. Sir, anyway, fantastic session, and I like to thank for the organizer as well as the participant, and also the for whom we are given these things. My questions are this: we have small and micro industries. Okay, so there, how this particular AI for the manufacturing and production planning can be implemented, and what is the cost? Because our entrepreneurs are having only 2 CNC lathes, 2 VMC lathes, and they want to implement the AI. I am audible?
Yes, sir, you're audible.
Yeah, and the second thing is in the sheet metal area, one of our member is supplying the lakhs together small sheet metal components, which has to be inspected in a quality, particularly AI implementation in quality. So
Yes,
this
understood.
thing, how it can be taken, and what is their ROI rate? That means return of investment, and what will be the cost implementation? And is there any case study for this micro and small industries? Please.
Okay, sir. So to be very precise, it is like not specifically for a micro and small industry. Maybe you said that if there are a minimal number of lathes and minimum number of machines are minimal, but ultimately we take it up as one machine or one asset that is going to be connected. Because when we go for implementing predictive maintenance to customers as well, initially we'll go for a pilot implementation where we take one machine or 2 machine or 3 machines, depending upon the plant size, depending upon their size that they have, the production unit that have the number of machines that the production unit is having, and we go for them. We go to them. We do the feasibility analysis. In terms of feasibility analysis, I say there is a machine, there is a conventional machine that is running, and that is very critical for the user. For example, you have a conventional lathe or a CNC lathe, a CNC machine that is not highly advanced and requires some amount of data connectivity to be incorporated. You can have this condition monitoring implemented first, where you will be able to know what is the current operational status, or at what condition or what health this machine is running now. And probably with amount of time, the customers will be able to realize the business value, and they will be gradually scaling up. So that is one way. That is one part of the question that you asked for, and that is how we go with implementations as well. And in terms of sheet metal analysis, what we generally do is we pitch in, we see to that in the best possible lighting setup, and that is like to start at a high level. I'm telling you the best possible approach that we can follow, and what are all the initial data that we can give in for the model to learn from the past historic data, the failure data, or reports, incidents where the customer has given that this is not good and this has to be rejected. The models are being built, developed, trained, and customer, they will be able to realize the business value as well. And regarding the ROI part of it, maybe at the moment I'll not be able to tell you, or if we can discuss further on that as well, it would be even better. Like in terms of how many machines that we are connecting, or even if it is for one machine, and what is the challenge that the machine is providing now, and what solution we can put forward, and how customers can realize ROI. Maybe I think we can take it up as a detailed discussion if possible.
Sir, please can you share the details of contact, and so that I can send some more details to you, please.
Yeah, sure, sir. I think I can do that to the meeting organizers.
Dr. Bibeye, can we take 2 last questions, please?
Yes, please, ma'am.
Okay. Ms. Jayapriya, please go ahead with your query. Or Mr. Akash or Mr. Deva, please go ahead with your questions, sir.
Yeah, ma'am. Automated report and traceability, what kind of AI agent can be used? Hello?
Yes, Akash?
Yeah, sir. Automated report and traceability, what kind of AI agent can be used?
So these AI agents are all customizable, Akash. So I think as I showed you, in the slides that I showed you, that one part of it is a reporting agent. It shows you as tables, and that can be downloaded as a CSV file. So it is not particularly this agent should be used. We develop customized agents that can do the pre-defined tasks which are to be done when a command is given.
Okay, sir. Okay. Thank you, sir.
Thank you.
Okay. Thank you, Dr. Bibeye, for such a wonderful session, and thanks for taking your time to address the queries of the participants also. Thank you very much, sir. We look forward to having a detailed session in the near future. And thanks to all the participants for making it convenient to attend this wonderful and knowledgeable knowledge sharing session. Thank you once again. Thank you once again, sir.
Thank you, ma'am. Thank you.
Have a good day, all of you. Thank you.